Hello, families. It's Mr. Mullen. We're doing some new kinds of word problems, and you guys are seeing those at home, and I'm guessing probably getting some questions because, frankly, the kids are a little puzzled by it at school. We're going to keep practicing and working on it, but I wanted to give you guys a little rundown so if they needed support, you could help them out. So, a bar model is just a way of drawing a picture to represent a problem. And one of the advantages to bar models is that they're really simple and you can apply them to a lot of different kinds of problems. So in the earlier grade levels, students are very concrete, and so they'll actually want to draw pictures of whatever it is they're counting. But obviously, as we get into higher numbers, that doesn't work. So kind of doing this representation works a little better. In this problem, there's two kinds of bar models. One is a bar model where you're going to be counting more than one thing, and you're going to use more than one bar for that. And then the other kind of bar model problem is one where you're going to break apart a bar into different parts. So this example problem here says David jump roped 240 times. David jump roped 249 times. He beat his previous record by 58 points. What was his old record? So in this problem, we know that he jumped and recorded it 2 times. One was the old record and one was the new record. And we also know that the 249 times beat his previous record. So that's the new record. So that would be 249 points. And then this old record is the one that we don't actually know. And the part that we're trying to find here is if we take away this difference between the two rounds, so we find out what the old record is and take out that 58 points, that will give us the old record. I may have said that incorrectly, but so one of the main goals for the bar model is for the students to show that they understand what the problem is actually representing. And then once they have it, it'll hopefully be a lot easier for them to figure out how to solve it. And these kind of bar models can use multiple bars, so it gets easier for them as they have more bars. They're still able to represent it and understand what they're solving for. So in this problem, because they had 249 on the new record, and we're trying to figure out what his old record was, they would take 249, subtract 58, 1, and then if we wanted to group these, we could group the tens, or the hundreds and the tens. So 24 tens minus 5 tens would give us 19. So the answer is 191. Or they could also do the standard algorithm and do regrouping also. So the answer for this would be 191. Another thing is I'm working with them to label their answers so that they're showing what they're solving for. So you could say 191 is the old record, or you could say he had jumped 191 times. So there are different ways that they could label them, but it's important that they show what they're actually solving for. Okay, so that's one type of bar model. The next type of bar model is one where they're breaking apart. So in this example, this is actually the one we used in class. So Cecily had 2 hours because of late start. She spent 60 minutes sleeping, 35 minutes watching Despicable Me. How much time does she have left? So with this kind of problem, we're only measuring one thing, and that is the time that Cecily had. This problem is actually a little trickier even than a typical problem because they have to see the 2 hours and know that that needs to be converted into minutes for them to solve it. So we would know Cecily has 121 minutes. That's the total amount of time that she had. And then she spent 60 minutes sleeping, so that's about half of it. So it doesn't have to be exact. It's just important that they know the relationship. So if there's an amount that's bigger than another amount, that part of the bar should be bigger. But 60 minutes is about half of the bar. And then she spent another 35 minutes watching Despicable Me, which is a little more than half of what's left. So you could say sleep, $60, TV, 35, and then we're trying to figure this part out. This is the problem we were working on today, and this was very confusing to the students, but there's a couple of ways they could do it. One is they could start out with the 120 minutes and then take away the sleep and then take away the TV. The other way they could do it is they could put the sleep and the TV together because that's this part, and then subtract it from 120 minutes to get the missing part. I'm going to go ahead and do the 120 for the total amount of time they had, and sleep and the sleep time and the TV time are 95 minutes. So I'm going to just group those together. And so then their answer would be 25. And then once again, they need to relabel that. So 25 minutes free. And I'm sorry for my sloppy writing, but I'm trying to write with a mouse. So there you go. Hopefully that gives you a general gist of what they're supposed to be doing. As with a lot of these things, they're learning different strategies. It's not essential that they have this all 100% correct right away. It's more important that they're filling up their tool chest for how to tackle the word problems and how to think about them, because a lot of times in third grade they're transitioning from trying to just take the numbers and try to figure out if they're supposed to subtract them or add them and actually think about the problem. A lot of times there's going to be like missing parts and they have to realize that and figure out how to do it, or there might be more than one part and they have to try to synthesize that. So hopefully that's helpful. This was a little longer than I was hoping, but if you guys have any questions, feel free to email me, and I hope you guys have some good luck with your math. Bye.